Hello and welcome to Ms. Ma's Advanced Functions class. This is 3.6, Factoring Polynomials. So we're going to start with a question that we have been able to answer with the scales from 3.5. Usually you would just take this question and you would do the long division. You'd be able to find the remainder. So why don't you pause the video and you could try that right now. As for me, I've actually already done it. It's down here. And if you want to see the whole thing, you can go ahead and download the PDF from the website. I just wanted to point out that you do need these placeholders, so just a reminder to get these placeholders in and to put in standard form. You should get that the answer is 38. So this is a okay method, but it is a little bit arduous. So there is a better method for this. And it arises from this theorem. It's called the remainder theorem. When a polynomial f of x is divided by x minus a, the remainder is f of a. And that's really useful because, instead of doing that whole long division, I can just plug in a number and I'll be able to find the remainder. So this is the exact same question, determine the remainder when I do this divided by this. And so first of all, I'm going to just let this be g of x, and then I'm going to find g of negative 2. So you have to change the sign here. So see, it says x minus a, so change the sign. So g of negative 2 is negative 2 times negative 2 cubed plus negative 2 to the 4 plus 6. And if you do your algebra right, then you should get 16 plus 6, which is 38, which is the exact same answer we got using the long division, but much quicker. So while we do like this theorem and it's much more efficient than the long division, it's actually the most useful because of a corollary that arises from this theorem. A corollary is something that's attached to that theorem, and it's based on this idea. Remember that if the remainder is 0, the divisor is a factor of the dividend, as in, if you have 35 divided by 7 and the answer is 5, remainder 0, that means that 7 is a factor of 35, right? So that's what the theorem says. It's actually called the factor theorem. When a polynomial f of x is divided by x minus a, the remainder f of a equals 0, then x minus a is a factor of the polynomial f of x. So I can test to see if something is a factor by just plugging in the a and then finding the answer. So we're going to do that to factor. And that's really good because we need factored form in order to graph things and things like that. So here are a few steps that we have to follow in order to do this complete factoring. Step 1, we should label the function because we are going to want to plug it in, and we should have a good notation for that. You'll use function notation. And then step 2, if you can, you should common factor it. Always common factor first. It makes numbers much smaller and easier to work with, and that's something that's really important when we're trying to work for speed. So in this case, I can't common factor. And then it says find the possible rational roots. These are often you'll hear me say PRR, find the PRR. So we'll call those PRR. And you do have to write them out. So we write PRR. And how we find that? Well, if a sub n, the leading coefficient, is equal to 1, it's actually not hard. You just find the constant term and you find all of the factors of the constant term. Okay, so we're going to do the factors of 24. And we have to do the plus minus of those, so we write them all out. And don't get lazy and not write the plus minus because it's possible that it's positive or negative, and we just want to make sure we get all of them in there. So these are all the factors of 24. You can just divide 24 by whatever takes your fancy, and you should be able to find these possible rational roots. Okay, so now we'll plug them into h of x, and we'll see which ones give us 0. There's no real method to this, it's kind of random. You don't know where to start. That's okay. I usually just start at 1 because 1's the easiest. But you can use your noggin a little bit, and you can see here that probably if I use 1, it's going to be too small of a number. So I'm going to start with 2 and then see how that works out for me. So I'm just going to erase this because I can't really read my polynomial there. Okay, so here we'll use f of x, h of x, and maybe I'll use 2, positive 2, and just plug it into the formula here. So it's 2 cubed minus 5 times 4 minus 2 times 4, 2 times 2 is 4, plus 24, and you can see that this is not going to end up being 0. So you just say not equal to 0. And then h of negative 2, you can plug that in as well, so it becomes negative 2 cubed minus 5 times positive 4 minus 4, this is plus 4 plus 24, and this is negative 8 minus 20 plus 4 plus 24, which is 0. So that means that x plus 2 is a factor. So you can stop as soon as you find a factor because Oftentimes you just need to do the 1, and you'll see why in a little bit. So we'll use this and we're going to divide. So step 4, we tested the PRR to find something that is equal to 0, that's what we want, and then we're going to do long division step 5. So you just plug in your factor here, and you put your polynomial in here, and I'm not going to dwell too much on long division. If you want to review that, you can go back and watch 3.5 again. We'll just do this really quickly. If you want to follow along, you can always pause the video and see if you get the right answer. And of course, we do want to find that the answer, the remainder, is 0, because that is kind of the whole point. If it wasn't 0, then it wouldn't be a factor, and then, you know, that would be a problem. So it means we messed up somewhere. And you can see that, yes, thank goodness, it is 0. The remainder is 0, and that's good. So now we have our solution. So we know that h of x is equal to x plus 2 times x squared minus 7x plus 12, which is, you know, that's the factor and this is the quotient. So we're not fully factored yet, but the next question we ask ourselves is the quotient a quadratic? If it is a quadratic, then we can do step 7, which is factor that quadratic, because we're really good at factoring quadratics. Since grade 10 we've been doing it. If not, we're going to have to go back up, all the way up here to step 3, and start the whole process again. Luckily, this quotient here, x squared minus 7x plus 12, is a quadratic, so we can just factor that. You can use the quadratic formula again, or, you know, if you know the answer, you can just factor it. I know that this is x minus 4 times x minus 3, and so that is in its fully factored form, and we are done. Yay! Example C asks us to sketch, and of course that means that we want to factor. We're going to try to factor this thing. So for step 1 is m of x, label it, and then common factor is step 2, which of course we can. And again, if you want to pause the video, go ahead and do that, and you can try factoring it and sketching it on your own. See if you can figure out what the steps are. So once you've got that, you can see that this 2x is sitting on the outside, and I don't have to care about that now because it's factored. So I'm only going to worry about this middle part, and I'm actually going to label it. I'm going to say, let's call that j of x. And so we're going to do the PRR for j of x, and we're going to test j of x, and we're going to divide j of x. That's what we're going to do. So the PRR for this one, and you can see it's slightly different. We actually have a sub n of 4 and not of 1. So we're going to use that 4, and we're going to use this 9, and we're going to ignore the numbers in the middle. So the PRR of, well, the factors of 9 are plus minus 1, plus minus 3, and plus minus 9. So you write those out first. And then you look at the 4, and you say, okay, what are the factors of 4? I know that they are 1, 2, and 4. And these are going to be the denominators. So I'm going to copy these numbers in and then put them over these numbers like this. So plus minus 1 over 2, plus minus 3 over 2, plus minus 9 over 2. So again, you can see I'm doing 1, 1. I'm just copying these numbers in, 1, 1, 3, 3, 9, 9, and then I put the 2 in the bottom. And I'm going to do the same thing with the 4. So I copy the 1, copy the 3, copy the 9, and then we're going to put them all over 4 like this. And those are all the possible rational roots. And that's how you find them if you have a leading coefficient that's not equal to 1. And then you can just erase with a smaller eraser these guys, and you can test these PRR out. So let's do that. We're going to plug these in. And you can just use your calculator to do it. You just type it in, so 4 times 1 minus 25 times 1 plus 21 times 1 minus 9, and that is equal, well, it's not equal to 0, and that's what we care about, so you can just write not equal to 0. You don't have to write the number. If it is wrong, I will take off marks, so you might as well just put not equal to 0. And you can test these in whatever order you like. Obviously, it's easier to do the integers first. I actually know the answer, so I'm just going to write it in here. J of 3 is equal to 0, and you can type into your calculator and figure it out again, which means that j minus 3, silly, x minus 3 is a factor, so we're going to divide using x minus 3. So let's see, I'm just going to put this out, and we're going to put x minus 3 here. And again, we're only using j, we're not going to use m, because we just need to worry about the thing that is not yet factored. So 4x cubed minus 25x squared plus 21x minus 9. So why don't you guys pause the video and do that on your own. I'm also going to pause the video and I'll come back to you when it's done. So now you can see I have divided and I've got my answer with a remainder of 0. So I'm just going to write my m of x in factored form. It's got this 2x on the front and then j of x, which we just factored. So it's 2x times x minus 3 times 4x squared minus 13x plus 3. And we'll factor that quadratic. Becomes 4x minus 1 times x minus 3. And if you have any doubles, like this x minus 3 is doubles, you just put them together. X minus 3 squared. We are going to have to sketch it, so we do want to know what the order is. And that's why I want to put these together. So actually we'll just write that out right now. The zeros and the order. Here's this one's x equals 0, x equals 3, x equals 1/4. And the order is 1, 2, and 1. If you go back up, you can see what the leading coefficient is. The leading coefficient is 8. It's positive. The y-intercept is 0, of course. And the degree is 4, so we know it's opening upwards. I could just write that in there. You don't have to write it, but I'll write it. Okay, so now we'll just put these zeros in. Before you do that, make sure you label your axes. And we'll put the zeros in. Ooh, not there. 0. Go in order 1/4, and this is not going to be to scale. I know your book often shows it to scale. What's most important when you're sketching is that you just make it nice and clear for your reader. So, you know, I know this isn't close, but it's going to be easier to see. So that's why we want to make it look like that. So we're opening upwards, so it opens like this, and we're going order 1, order 1, order 2. So I will just try to do my best to make a nice symmetrical graph and get a parabola. Ooh. It's very difficult to draw in one line, so you can always do it in pieces. Just trying to make it nice and curvy and, you know, not too obvious. And there you go, and then we can label it m of x. Another good reason to label it originally, that way I don't have to write the whole equation out. So m of x, and there's our graph, and we're done. The next part, I just want to give you a chance to practice finding the PRR. So why don't you pause the video and find the PRR for this. I will come back to you when I have written them in. So please check your answer and make sure that you got the right thing. This is the answer in its full glory for this 15x cubed plus 14x minus 4. However, for the PRR of 6x to the 4 plus 5x cubed minus 15, we do actually have to cancel some things. And you can just erase the ones that we don't need. You can see that 3 over 3 is actually 1, and we have 1 in the list already, so we can erase it. Or if you have a very difficult time erasing things, then you could cross it out like that. We'll cross out anything that cancels because it's already in the list, and there you go, you have your full list of PRR. So we have one more example. When 2x cubed minus mx squared plus nx minus 2 is divided by x plus 1, the remainder is negative 12. X minus 2 is a factor. Determine the values of m and n. So the first thing that we're going to do is we're going to label this, and let's let that be f of x. And we'll notice that f of negative 1 is equal to negative 12 because the remainder is negative 12. X minus 2 is a factor, so f of 2 is equal to 0. And we're going to plug this in, and you'll find that we have two equations with m and n, and we can solve that system of equations. So the first one is f of negative 1 equals negative 12, so negative 12 is equal to 2 times negative 1 cubed. Make sure you keep them inside the brackets there, the negative numbers. Otherwise you're going to get the wrong answer and it'll be a bit of a mess. And so we can just simplify it down. We're going to get minus m minus n minus 2. And just move everything over so it becomes negative 8 equals negative m minus n. And you can factor out the negative 8, or you can leave it the way it is. I'm just going to do it this way. And then we have f of 2 equals 0, so 0 is equal to 2 times 2 cubed minus m times 2 squared plus 2n minus 2. And you shouldn't skip this substituting step, it's really important. I'll write it in, and we get 8 minus 4m plus 2n minus 2. Move it to the other side, so negative 6 equals negative 4m plus 2n. And depending on what you want to do, I think I'm going to divide by negative 2 so that I get 3 equals 2m minus n. So this is our first equation, label it 1, and this is our second. I'm going to use elimination, but you can use substitution if you like. If you don't remember what I'm talking about, you might want to go on a website and just double check. I'm going to add these two together, 1 plus 2. So we'll get 8 equals m plus n, and 3 equals 2m minus n. Just add them together, and you can see this is 11 equals 3m, and we cancel the n, which is what we wanted, so m is equal to 11 over 3. And we'll substitute it back in to one of the equations. Doesn't matter which one, I'll use 1. So 8 equals 11 over 3 plus n. So n is equal to 24 over 3 minus 11, 13 over 3. And there is our solution. Okay? So thanks for watching. Bring any questions you have to class, and I'll see you soon.